Okay, today on the bench we have a realistic TRC-448. This is a 40 channel AM sideband radio. Actually, this one's more than 40 channels. Someone had done previously a channel modification to this, and unfortunately they drilled a hole in the bottom cover. I hate it when people do that, but it's done, so yeah, what can you do about it? The customer did ask if I would relocate that channel modification switch and use the monitor PACB switch, so that's what I did. And that in itself is a chore. This is a very large switch in, maybe just a little tiny knob from the outside, but on the inside, yeah, there's 4 rows of 4 terminals, and there are a lot of wires that go to them. So if you ever want to do something like that, especially on this model radio, you've got your work cut out for you. There are a lot of wires to remove off of that switch and then splice the correct ones back together so the radio works in CB. I just need to turn this thing off. As you see, it's got a blue display. That's another thing he asked for, was change the display out from the original red display here to a blue display. Did that, and yes, it's just blindingly bright. I cannot stand blue for that reason. You see that, at least looking through the viewfinder, you see that big blooming ball of light? That's what it looks like when I look at anything that's blue. I cannot stand blue. It is the absolute worst color there is for displays, just because you get that light bloom effect. Red and green are the best colors for displays, honestly. That's why that's what they use in test equipment. But it is what it is. Other thing he wanted was change the LEDs down here. Those have also been replaced. Originally this had all red LEDs for the AM lower and upper sideband. He asked if I could change those to red, blue, and green, so that's what I've done. I don't know if I guess I already tossed them. I've got a pile of parts over here, stuff that's been replaced, but some of the stuff has already gone to the trash can. It's already made it to the circular file. Those LEDs were one of them. Kind of a little bit challenging even getting the LEDs in there. The original LEDs, I'll just use a capacitor, actually a large one, be easier to see, as an example. Normally, an LED, like the ones that I installed, the terminals are spaced like this. They're evenly in from each side. So you have the center, they come out an equidistant amount, there's a terminal, and then again an even distance between the terminal and the outside edge. The original LEDs in this were not like that. I think it was the anode, or no, was it the cathode? Right off the top of my head, I can't remember. I think it might have been the cathode. The cathode was almost dead center, and then the anode was spaced out really close to the edge. Wouldn't have been too bad, but these LEDs are mounted differently. One mounts anode to cathode, the other one mounts cathode to anode, and then the third one mounted anode to cathode, like this. So you've got, and if you install normally spaced LEDs, modern LEDs, they're going to be offset like that, either one direction or the other, because of the terminal spacing being off a little bit. So when you install, now luckily they actually had a little plastic spacer underneath of those LEDs that spaced them up off the board about that far. So not using that, you're able to bend the terminal leads a little bit to keep the LED up off the board. Bend the leads a little bit so you can get them in the line, so they're in line with the holes right there. But pretty much anything you do to one of these radios is a challenge. They were not designed to be worked on. For starters, anything you do up front here, you're screwed. Most people are probably familiar if you worked on radios. If you need to work on something in here, especially a good example would be this squelch or clarifier control. The back side's extremely close to the circuit board there. Normally, if you needed to change that, really simple. You'd take out 2 screws on either side of the bezel, take off the knobs, you'd pull the bezel off. Then there are usually 1 screw on either side that holds the sheet metal structure and screws that front sheet metal structure to the side. These radios are not like that. The front sheet metal structure on these is tack welded to this side. You can't take it off. All of the parts on this front were installed before the chassis was installed in it, so yeah, it can be a little bit challenging. Luckily, this switch, because of course this switch that I had to rewire, again, is really close to the edge of the circuit board. But luckily, at least they had their thinking cap on for that. And they have, those actually mount to another little bracket in there, and you can take the screws off of that bracket. And you can't get it out too far, but you can get it out enough to get to the wires on the back of it. But yeah, just challenging. And it's challenging to work on the circuit board on the other side, and I'll show that in a minute. Now, one thing I kind of don't like about these is the banana circuit board, probably the best way to put it. I don't know how it shows up in camera, but this is there. I'll tilt the camera up and look down at it here in a second, but there's actually two circuit boards here. You've got your PLL synthesizer, microphone, amplifier. There's a lot of stuff goes on in this front board, and then you have the rear board. The rear board, actually the front's got a little bit of a buckle to it, but that rear board has a pretty nasty buckle to it, especially at the front edge. At the back end, it's fine. It's screwed along the, all three sides, but there's nothing attaching, or supporting the center of the board here, up here at the front edge. So this thing is buckled like a banana. To make matters even worse, and I think it's probably what causes that, turn around here and grab it. From the factory, they have this thing in here, apparently. This block of foam. So, yeah, block of foam, which isn't too bad, except for stuff like this and this and this. As you can see, the indentations in this, that's pushing on this foam. Now, granted, foam's nice and spongy, but still, over a period of 30 plus years of continuous pressure on that, that just slowly buckles the board. Now, it's not like it's split, and it's very unlikely that it's going to. It's just that it is buckled a little bit. So, yeah, it was kind of a... They almost needed to, in my opinion, put like a solid bar across between these two boards. I'll get the camera up here so you can actually see what I'm talking about. You can see there's a split right here. This is one board, this is another board. They almost needed to run a solid support tying the two sides together, and then have a screw come up basically here and a screw here to fasten these boards in the middle here, because like I say, it just kind of sits in there and flexes, but it is what it is. So if you're going to recap one of these like I've done, this shield can actually stay on. There's not really a lot going on underneath here as far as anything that you'd have to service, but this one definitely has to come off. Fairly clean design, at least on the bottom side. There's not a lot of bodge parts. I can get everything unplugged here so we can get her flipped over. Resistor, couple capacitors on here, they're all factory. This resistor was changed. That's a new one, actually. Where is the original? It's laying over here in a pile. That was this one originally. Had the Sony Bond glue on it, or that corrosive glue, so I just went ahead and it's just cheaper and easier. Just put a new resistor in than it is to try and clean all the gunk off of that one. So, to the business side. Oh my God, what a nightmare. I've worked on these before. Now, actually, I can show you on the other side. For starters, you're probably looking at this. Some people might look at this and think, is that a Cybernet? They know just by looking at it instantly it's not a Uniden, but some people might look at it and go, is that a Cybernet chassis? No, absolutely not. It is not a Cybernet chassis. It is a GRE. Not agree. It's GRE. G-R-E. Zoomed in here, and you can actually see it on the board right there. So, GRE, made in Japan. GRE, actually, what the heck did that stand for? General, it wasn't radio, I think it's General Research of Electronics Incorporated or something like that. They did make some CB chassis. They weren't as prevalent as, say, Uniden or Cybernets were, but they did make some radios. They're probably more well known for, back in the day especially, shortwave radios and police scanners and stuff like that. Realistic did use a lot of their products, especially in a lot of their radios. Like I say, there's little short, even small, big, whatever size, but they're portable shortwave radios, even base station style shortwave radios. They made some scanners and all kinds of electronics, but they did make some CBs. And they're actually really good working radios. It's just, design-wise, from a technician standpoint, these things are a disaster. Oh man. And it's not that they're unreliable, it's just that it's working on them is physically a challenge. Like I say, this welded on front sheet metal structure here is a big one. The other thing is, if, this radio, good example, decades down the road, you need to replace all the electrolytic capacitors. That is a chore in this thing. For starters, there are a lot of them. There's all the caps. That's one thing I hadn't thrown out yet, was all the electrolytic capacitors. Like I say, some of the work I've done to this, I've already tossed some of the parts, but yeah, there are just a lot of electrolytic capacitors in this. And unfortunately, a large majority of those are buried underneath of all this wiring harness. And a large majority of those are all located right here, right along the front edge and down underneath all of this wiring harness. It is just packed with electrolytic caps down in there. They're just all over the place down in there, and trying to get to them to service them is a bit of a pain in the butt. Luckily, they're, at least for me, they're fairly easy to find, the solder connections on the other side of the board. But yeah, just on the top, just access, getting down in there, even once you cut all the wire ties off of here, because originally it had these little ball link style wire ties. But even once you get those off, it's still trying to pull the wires out to get down in there. It's just, It was, yeah, but a lot of vintage radios were like this. Just huge bundles of wire. I mean, it just looked like a bird nest, but they work. And actually, these work really well. They're really good sideband receivers. Again, nice big crystal filter like you'd expect in a vintage sideband radio. And interestingly, they're even labeled Gree, even though Gree isn't the one that made them. It was made by, I'm trying to read this upside down. What is that? Hashikosha. From in Japan, but yeah, they even had them private labeled Gree, I guess. But yeah, standard 7.8 megahertz sideband crystal filter. Really good receivers, good transmit. These are relay switched radios. These are not solid state switched, so they do have a relay in them. As you can see, pretty dense with transformers and chokes back there, and just very densely packed, period. There's a lot going on in these radios. The PLL's actually crammed way down in there, and God, for the life of me, I can't even remember and get the service manual out here right off the top of my head. It is, no, it's a rec. What is it, rec? Yeah, it's a rec. 86345 is what the PLL is in that. But and they have a little bit of a, I don't want to say unique, but different mixing scheme, just the way they do things. But again, a lot of people were familiar with looking at either Uniden or Cybernet. This was another company. They came at it, their engineers came at it from their own point of view and just did things differently. I mean, like I say, they came up with a really nice radio. One of the nice things I kind of like about these, yeah, it may have lots of wires, but where a lot of these wires, or where actually all of these wires attach down to the board, especially stuff like, like this one here and these little black ones here, those are actually coax cables. It's very easy to trace out stuff. Even with having all of these wires, it's still easy to trace them out, because I don't know if we can get down in here to focus on it or not. Yeah, you can probably see that. But they label everything. So you can see right there, this is the 7.8 megahertz from this, on this cable coming out from the synthesizer board down. Everywhere there's a cable, there's, you can see, this is the VCO, got to get the light right. This is the VCO output right here. But yeah, very nice. I mean, like I say, very well labeled. So from a tech standpoint there, big thumbs up. Lots of labeling, because sometimes that's a challenge, trying to trace wires and figure out where it's at on the board, especially if somebody has modified a radio. You don't know where a wire was originally. Finding it on a schematic in a service manual and trying to actually find that hole in the board somewhere. Because just because yeah, there's a wire needs to go to, let's say, a component like this transistor. Well, that doesn't mean the wire is going to be right here. The wire may attach to the board way back here, and there could be a circuit trace running up to this transistor. So yeah, having the board labeled, it's actually really nice being able to find stuff like that. So like I say, thumbs up to their design team there. The bias is a little bit weird to adjust on the driver and final on this. the final's fairly straightforward. It's like anything else pretty much. You remove a jumper link. So they actually, what they used was a crystal socket. Zoom in here again. They have a crystal socket right here, and then they just have a little jumper wire just pushed down into that. That's the bias link for the final transistor. The driver, on the other hand, doesn't have one. There is no jumper link, and you don't adjust the bias current on this. What you're supposed to do is just transmit a double tone in sideband, and then adjust the bias pot for the driver for minimum distortion. And that actually does work, and I've tried that with other radios, just, you know, curiosity's sake and experimenting a little bit. I think I've even talked about that in a few other videos. You know, trying that on some of the classic chassis from other manufacturers. So like, you know, Cobra 2000 148 chassis. Same thing with like Cybernet chassis, like the PLL02A style chassis. And it works on some, doesn't work so great on others. This one, it was designed to be adjusted that way, and the experimenting I've done with those other chassis where they actually have a jumper link, and if you adjust them for, what I found was if you adjust the driver and the final for minimum signal at 54 megahertz, so you're adjusting the bias currents for minimum second harmonic, and then you come back in and you actually check the bias current against, you know, whatever the service manual, let's say, might tell you it is, you'll find it's almost exactly dead on. Yeah, it's surprising how well that works. So that's what they have you do, adjust for minimum distortion on the driver. Actually, 54 megahertz second harmonic suppression on this thing is amazing. It was like 86 or 87 dB down. You know, but one of the reasons that can happen is this one's actually capacitor tunable as well. So there's actually a variable trimmer capacitor hiding underneath the speaker wires right there. But yeah, the second harmonic, man, you can completely squash it out. It's just gone. Carrier suppression's also really good on these. Again, kind of it's not unique because they did make a few different radios, and there's some other manufacturers that have done this, but to adjust for minimum carrier on these, there's actually 3 adjustments. There's a trimmer resistor, there's a trimmer capacitor, and there's a tunable coil. So there's actually a coil, cap, and a resistor that all get adjusted for minimum carrier suppression. Again, having all of that adjustability means you can really get the second not the second harmonic. You can really suppress the carrier really well with these chassis. Like I say, they added a lot of parts. Normally, most radios wouldn't have that. You know, cost more money, but you know, I kind of get the feeling they were, I don't want to say they went all out, no expense spared, but some of these circuits are designed where it looks like they kind of had that philosophy compared to where some other manufacturers, usually like for carrier suppression, the only thing you're going to find is just a trimmer resistor. But yeah, like I say, circuit works really well. Does have some extra little shielding cans here. Yeah, and the layout's a little bit different. You've got some of your power regulation and your audio circuit back in here wraps around to the back, and then your driver and final, instead of being along the back, of course, they're over here along the side, kind of like Cybernet chassis. Yeah, just this spongy board. I don't know if you can see how much that flexes. You know, that is where it should be. That's where it's at. It really, if I get the camera angle right here, you can probably really see that. That is where it should be. That would be flat. That is where it lives, just because it's bowed. But like I said, I don't think there's really any chance of that board cracking, especially having all these shields around here. It's just really, it is rigid, but it does, man, that just drives me nuts when I see circuit boards buckled like a banana. I guess there's not a lot else to say about this. Oh, I did have to put a new power cord in. Yeah, the power cord was like that long, and then someone had tacked another power cord onto that power cord, so I did replace the power cord. Had to stick in a larger strain relief because the power cord that's the only thing I will say. Man, the wires that they had for the power cord, little teeny tiny things. I mean, they were just barely, it's like almost like a joke. Little tiny strain relief. So yeah, this thing wouldn't even fit over the original cord, so I stuck a new strain relief in there. And the black goop, that's just speaker adhesive to keep it so it can't rotate. Let's see, anything else worthy of mention in these other than there are just so many adjustments. Yeah, there's just more adjustments in these than a standard radio, especially in the oscillator, PLL circuits, VCO and whatnot. Yeah, there's just a lot of adjustments in here. And they're weird because, like I say, some of your audio circuits up here, some of your audio circuits back here. So some of your microphone amplification adjustments and your AMC adjustments actually appear on this board, where your sideband ALC circuit, that's back here. It's just, yeah, it's, having worked on mainly, when it comes to mobile radios, I'm sure most people are like that, mainly Uniden or Cybernet chassis, you work on one of these and you kind of think, man, what were they thinking? It's not that there's anything wrong with what they did, it's just different than what you're used to seeing. And you can see actually when this radio came out, this radio is in the same service manual as the Cobra 2000 GTL, so that gives you a time frame of when this thing came out, March 1979. So it's not like it's a really early solid-state rig. This was, same time the Cobra 2000 came out. So there you go. There's a realistic TRC-448. Oh, one other thing I had to do to this before I forget. Well, I did change meter lights, the normal stuff there. Let's see, what else? Unlock the clarifier on this. And, oh, mic jack, that's what I wanted to mention. This now has a 4-pin mic jack. This did not have a 4-pin mic jack. Another thing, pain in the hoo-ha. You got to remember, it's a realistic, so it had a 5-pin DIN. And there it is. That's what originally was mounted in the side of the radio. The problem is how this thing is mounted. It mounts directly to the circuit board. This is a 90-degree mount. So what they had was this little reinforcement bracket here. That's actually what it screws to. So you've got this like a piece of compressed cardboard insulation board. So the mic jack plugs into the board. This little black piece, I guess just for cosmetics, so you can't see sheet metal when you're looking from the outside. But they have that on the outside, and then this aluminum bracket that is threaded slides in from the backside. Again, where is all that at? Underneath all of this wiring, trying to get down in there. And then trying to get this mic jack installed in here, you have to keep the screws and everything flush, because the sheet metal here, you can't get out past this or your cover is going to buckle when you put it on. So yeah, also the mounting screws, you have to have you can see how flat the heads are, just so they just don't come out too much past this. In other words, they can't come out past this front sheet metal right here, the front structure where it's riveted on. But yeah, so got that stuck in there and wired up, and that works fine. But yeah, just like I say, everything is a challenge in these. I saw how that was mounted to the board, because I'd never replaced one of these, at least not that I can remember. So yeah, I haven't done one in any recent times. But when I saw this was, like I say, a 90-degree mount, I was like, oh, you've got to be kidding me. Trying to get that thing out of there. So there you go, realistic TRC 448 ready to be put back into service.